Hi everyone, let's use tables now to find probabilities. Example, let's say that you're going to roll two dice, two standard six-sided dice. What's the probability that you're going to get doubles or a six on either die? Now a formula might be a bit too complicated, but consider uh, a two-dimensional grid or table or array such as this, where we have the red die, the marginals here, 1 through 6, the green die, the marginals here, 1 through 6, and then the entries here correspond to the 36 ordered pairs, the 36 equally likely outcomes, forming the sample space for when you roll two dice, red die, comma, green die. So consider using this kind of table and try to consider more clever approaches using some of the warnings I've discussed before. I'll give you a minute to think about this. The more brute force approach using this table, this grid here, and perhaps more clever approaches. All right, you should get the answer of 16 over 36, or reduced, it's 4/9, or about 44.4%. Now, if you use this table here, all right, remember that we get doubles by rolling 1, 1, 2, 2, and so on up through 6, 6. There's 6 outcomes, 6 ELOs that correspond to doubles. Okay. Now, in addition, we have 6 ELOs that correspond to a 6 on red, and then 6 ELOs that correspond to a 6 on green. Now, if you do it brute force, if you count these X's one by one, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Notice I'm only counting the boxcars case once. The 6, 6 case is going to cause us some heartache later on. We get 16 over 36, or 4/9. The brute force case, filling out this table like this, may be the best way for you to get at the right answer. If anything, you might be in danger if you try to get too clever. Because here's the deal. The probability of getting doubles is 1/6, or 6 over 36. The probability of rolling a 6 on red is 1/6, or 6 over 36. You can think of it as 1/6 as a one die problem, or 6 over 36 as a two die problem. Likewise, the probability of getting a 6 on green is 1/6 as a one die problem, or as a two die problem, 6 over 36. So a naive student might just add, oh, well, 6 plus 6 plus 6, 18 over 36. I guess that's my answer, 18 over 36, or 1/2. That's going to be wrong. And why is that? Because you're supposed to get 16 over 36, not 18 over 36. What's the problem? If you do this, you're counting the boxcars case, this guy here, 3 times. Once, twice, 3 times. 3 times. You're triple counting boxcars. So to adjust for the triple counting, you would have to subtract 2 over 36 to make sure you only single count boxcars, 6, 6. So again, the brute force case, the brute force approach might lead you to a more accurate result more quickly. Whereas if you're going to try to be clever, you better be very clever and make sure to not double or triple count. When you do this, you do get 16 over 36, which is the correct answer. Next, we're going to look at using a two-way frequency or contingency table where we have a table consisting of counts. Next time.